In this video, we'll do yet another example of finding arc length of the graph of a function over an interval. So we have the curve y equals x to the fifth over 5 plus 1 over 12x cubed. We need to find the exact length of that curve from 1 to 2 for the x's. So again, just like we have in the other examples, we'll take the derivative. The derivative of that function is x to the fourth minus 1 over 4x to the fourth. We'll plug that into our arc length function. So we have the integral from 1 to 2 of the square root of 1 plus the quantity x to the fourth minus 1 over 4x to the fourth squared. We're going to distribute out what's in the squaring here. And then we'll simplify under the radical and refactor. When we multiply this out, when we distribute everything, we'll get an x to the 8th. Notice that when you take the x to the fourth times 1 over 4x to the fourth, the x to the fourths cancel and you get a 1/4, and we have to do that distribution twice, so we get a minus 1/2. And then this, when we square it, will be 1 over 16x to the 8th. So notice that this middle term, when we distributed, was a minus 1/2. When we simplify by adding the 1 to it, we're going to end up with a plus 1/2 in the middle. So notice that these two expressions look almost identical. The only thing that has changed is the sign in the middle. So this expression now that's under the radical, where the x to the 8th plus 1/2 plus 1 over 16x to the 8th, that refactors almost identically to what we started with. It's just going to change the sign in the middle to a plus sign rather than a minus. So now we have square root of x to the fourth plus 1 over 4x to the fourth squared under the radical. We simplify, we just get x to the fourth plus 1 over 4x to the fourth. Notice that on the interval from 1 to 2, everything here is, well, actually everything's positive no matter what interval we're on, as long as we don't have 0 in there because we're doing fourth powers. But in particular, I don't have to worry about an absolute value here because my argument is positive. Now we do an antiderivative. We get a 1/5 x to the fifth minus 1 over 12x cubed. Notice that's almost identical to what we started with. Again, the sign in the middle has been changed. And these problems are rigged so that that's how it ends up a lot of times. Plug in your endpoints, simplify your arithmetic, and you should get 3011 over 480.